Gators, we're going to do lesson 2.10, finding the derivatives of tangent, cotangent, secant, and cosecant. Let's address the derivative of tangent. When we rewrite tangent, we can write it as sine of x over cosine x, and that's an opportunity to be able to use the quotient rule. When we use the quotient rule, remember this is our denominator right here, so we'll do cosine of x times the derivative of the numerator minus the derivative of the denominator times the numerator all over the denominator squared. We're going to find the derivative of this, and it becomes cosine x. The derivative of cosine x is negative sine x, which forces us to now have a plus sign over here all over cosine squared. We're going to get the Pythagorean identity, trig identity here. That'll become 1 over cosine squared of x, and then we'll have secant squared x. Let's take a look at the derivative of cosecant x. Let's go ahead and write it in terms of sine. Here's another opportunity to use the quotient rule. Okay, here's the denominator times the derivative of the numerator, which will go to 0, times minus the numerator times the derivative of the denominator over the denominator squared. So all we have is this portion right here, and the derivative of sine is cosine. So this is negative cosine of x all over sine squared. Now I'm going to separate this fraction, and I'm going to write it this way. And when I write it this way, we can see where the cotangent comes from, and we can see where the negative cosecant comes from right here. So there are 6 trig derivatives. Remember, I've done tangent, cotangent's done the same way. I did cosecant, secant is done the same way. It's important that you know that the common struggles for students dealing with trig derivatives is they just don't get down and memorize those 6 of them, and that's really what you need to do. You need to also know your unit circle values, simplifying and manipulating trig expressions, and being able to put trig reciprocals in the calculator. Here are the 6 derivative answers. Please stop the screencast and make sure you copy all 6 of them and get them memorized. Let's take a look at this next example. We're going to try to find the derivative of this product. So that means we're going to use the product rule. Y prime is equal to the sine of x times the derivative of the second function, which is tan x, plus tan x times the derivative of sine of x. Okay, and we continue, and this is going to be sine of x, and this will be secant squared x plus tangent of x, and the derivative of sine is cosine x. And you can just leave it this way. You don't have to do any more. There's your answer. Let's now take a look at finding the derivative of this rational expression. It's going to require the quotient rule again. F prime of x equals, and it's going to be secant x times the derivative of x minus x times the derivative of secant x all over secant squared x. All right, so now I'll have a secant squared x times 1, I won't bother to write that down, minus x, and then we're going to have secant x times tan x all over secant squared x. Now I'm noticing that I really prefer to do some simplifying before I actually substitute that 1 and find the slope of the tangent line. So I'm going to do this, and remember secant squared x means you're just multiplying it twice. And so I'm going to reduce so that my work, I have less work when I actually substitute, and so I'll go ahead and do that right now. I'll substitute pi 6, and that's going to be in my numerator. That'll be 1 minus pi 6, and the tangent of pi 6 is 1 over root 3. You're allowed to keep that root 3 in the denominator. And then the secant of pi 6 is the reciprocal of cosine of pi 6. So that'll be 2 over root 3. And you can just leave it that way. You don't have to simplify. It's okay the way it looks. All right, we're going to find the tangent and normal lines. Okay, so we want to find the equation of a line, which means we need a point and we need to know a slope. And to find the slope, we're going to take the derivative of this quotient. So on the next slide, I show you how to find the derivative. Here it is. And I got to this point, and now I'm going to substitute 2 in, and now I have my slope. Here's my slope. I need a slope to find the equation of the line. I also need to have a point. I have the x coordinate, but I do need f of 2. And I go ahead and put 2 into the function, and I use my calculator to find that value. Once I know the slope and a point, I can go to the next slide and show you the equation of the tangent line. I put the point in, and I put the slope in. Now it also asks for the normal, and the normal uses the same point, but it uses the opposite reciprocal. Normals are perpendiculars. So over here, I show that I just do the opposite reciprocal. I put it in the calculator, and this is the value. Let's take a look at a second derivative. The first derivative would be just to take the derivative of secant x. And now what I'd like to do is I'd like to use the product rule. And when I use the product rule, I will get the second derivative being this. So that's how you figure out the second derivative. And that's the end of the screencast.